to grab a highlighter. If you have a highlighter, feel free to take one out. You're always welcome just to come up to my desk, and if I have any highlighters up there, you can just grab them. That's not a problem. I'm going to start here. I'm going to make my dotted line, which is my horizontal asymptote, and that is at y equals 0. I'm going to come up to the side, and I'm going to plug in -1. If I plug in -1, I have 2 to the -1. That says 2 isn't happy, it goes to the bottom. So I'm graphing the ordered pair over -1, up a half. Then I'm going to do 0. Anything to the 0 is 1. I'm going to go to 1, 2 to the first power. 2 to the first power is 2. And I can see the general idea, and I've used the different points, and now I'm going to identify down here the y-intercept as 0, 1. Now let's take that concept and let's add it into our next one. So here I can see that I have had a vertical shift up 3. So I'm going to go up to 3. If you don't have this on your paper, please go up to 3, making that dotted line. That's obvious. We're going to come back and talk about this later. Recognize that this is -1 times 2 to the x plus 3. Keep that in mind. I'm going to make off to the side, and we're going to talk later about how can we construct this graph just based on the parent function and what I see. But let's start right now by making a few different numbers here. So if I plug in a -1, what I have, if I come up here, is I have -1. Now I insert a -1 into the exponent position, 2 to the -1 plus 3. I know this equates to 1 over 2. It's not happy, it goes down to the bottom. So I have -1/2 plus 3. Well, if you have $3 and you take away -1/2, that's -1/2 plus 3. I'm going to turn it right now into a fraction. I know that I'm comfortable saying that this is 2 1/2. But if you were not comfortable and you did not get to use a calculator, 3 can also be written as 6 over 2. 6 over 2 is equivalent to 3. And I go -1 plus 6 is 5. 5 over 2 is equivalent to 2.5. So I'm going to at this time go to -1, and I'm going to go up to 2.5. Here's 2.5 is right there. Now let's plug in 0. Anything to the 0 power is 1. 1 times -1 is -1. And -1 plus 3 gives us 2. I'm already getting the general idea of what this looks like. I'm going to come down here, by the way, and plug in 0, 2. I'll do one more. So 2 to the first power is 2. 2 times -1 is -1. And, is -2. And -2 plus 3 is 1. So I have my general idea here. I'm going to take this. We're going down. I'll find out exactly how many points do you need on each graph. I definitely need 3 points on each graph. Make sure to grab this when you come in, please. Natalia, would you make sure to help out anybody who comes in where to find the paperwork? Let's go on to the next one. So this next one, what does this say about the 2? Anybody, when you have a negative exponent, what do we want to do with it? A little bit louder. What do we want to do with this 2 when it has a negative exponent? Reciprocal. Well, they're reciprocal. Good mathematical language there. Okay, so I'm going to make myself another little xy here, and I'm going to start right away by plugging in 0. 2 to the 0, there's no such thing as -0. 2 to the 0, well, anything to the 0 is 1. 1 minus 1 is 0. So I'm going to go right away over here. Recognize that we do have a vertical shift of down 1. And I am at 0, 0. So 0, 0 would be identified as my y-intercept. I'm going to go over to the right 1. When I insert a 1 into this position, it's 2 to the -1 because there was already a negative symbol that was there, and then I subtract 1. Recognize that this is the same as the reciprocal, just like Jose said, so 2 isn't happy, goes down to the bottom. Now, if you have a half and you take away 1, we're left with -1/2, -1/2. I'm going to go over 1 and down a half. That already shares with me what the shape of this is going to be. That already shares with me the shape. I'm going to go to -1. I'm going to do one more, knowing that I need to have 3 points. If I type in -1, up here I have 2, subtract, and now I type in a -1 or write in a -1, subtract 1. Okay, well, 2 negatives make a positive. 2 to the first is 2. 2 minus 1 is 1. So I'm going to go over 1 and up 1, and we get the general idea of what this looks like. I'm going to come back up here. I want 3 points for each one. Okay, we can see here I have a vertical shift of up 2. Do I need to see it on your paper? Do I need to see what the horizontal asymptotes are? Yes, they need to be clearly defined. I will provide you a highlighter if you don't have one to use this. Can you use a calculator in this? No, you cannot. Okay, so for this problem, let's start by first just plugging in. I want to make this a 0. I want to make my life easy. Now, if we relate this to the other functions that you've done before, this is going to be your horizontal shift. Do you think we're going to go to the right 3 or left 3? Left 3, and I'm going to go, this is the up 1 shift, just so we have that in mind. So I'm going to start, actually, when I think about this, I'm going to plug in a -3 first. If you are unfamiliar with this, let me grab a piece of paper here. This is like f of x equals, that negative sign is a -1, and that's 2 raised to the x plus 3 plus 1. That is what we have to think about. So I'm going to start by plugging in a -3. And the reason for that is I know -3 plus 3 is 0. So I have a -1. 2 to the 0 is 1 plus 1. I end up with -1 plus 1 is 0. So I'm going to go -3, 0. I'm going to make a dot. 1, 2, 3. Please do the same. Now, I know I cannot cross over this horizontal asymptote, so I know it's not going up. Instead, I know it's going to be going down this way. So I'm going to choose points that are to the right. So I'm now going to plug in a -2. Again, I'm going to come back up here where you guys can see my work. I'm going to substitute in a -2. So I have a -1 out front. Now, when I substitute a -2, -2 plus 3 is 1. So 2 to the first plus 1. So I have -1 times 2 is -2, and -2 plus 1 is -1. I'm going to go over to -2 and down 1. Just about caught my ear there, didn't you? Okay, let's do one more. Let's plug in 0. If I plug in 0, I already have a negative out front. Now, if I plug in 0, we have 2 to the third. 2 to the third is 2 times 2 times 2, which is 8 plus 1. I end up with -8 plus 1 is -7. I have 3 distinct points here. This is 6. 7 is right down here. Make sure I can see this. And I have 0, -7. Generalizations looking up here if you've forgotten this while you did the homework. When there is a negative sign out front, think of this as a -1 times this quantity. What happens when there's a negative in front of the number? Instead of it going up, which way does it go? So notice how it goes down for part A, it goes down for part B. Next up, what is the difference between these two? When in the exponent position it's positive, it's up to the right, but when in the exponent position is a negative variable, it goes up to the left. That's because this is going to be, listen closely, when there's a negative in front of the exponent position of the variable, you're doing a reflection across the y-axis. When there's a negative in front of the number, it's a reflection across the up here, please. Let's look at this really quickly. I am going to ask for you to interject as I go through this. And if you think there's a faster, easier method, it cannot involve using a graphing calculator, please do so. The more problems you do with these, the more times you're going to be able to recognize, you'll be able to recognize these patterns. All right, so let's start with this very first one. I'm going to start by plugging in a 0. And the reason for that is I know that any value raised to the 0 power is 1. So I'm going to go and I'm going to come up here, making my horizontal asymptote because I see no vertical shift. There's no number behind. There's no vertical shift. So I have a horizontal asymptote at 0. I go up to 0, 1. Now, recognize the difference here. Here I have, right here I have a whole number, but here I have a fraction. So how may that look different? How may that look different? Do you guys remember learning about exponential growth and exponential decay with Ms. Castro or Ms. Mordiat? Okay, so exponential growth is going up to the right. Exponential decay is going to be going down to the right. So sometimes think about like the value of a car over time versus hopefully the value of like a house over time that's growing. So I only want to do 3 points and I want to do the least amount of work. I'm going to type in a -1 or write in a -1 here. When I do that, what it does is it causes what Jose said, there to be a reciprocal. So if I flip this around and I go 1 over 3 raised to the -1, when I apply that, I get 1 to the -1 over 3 to the -1. It's not happy, it goes to the bottom. It's not happy, it goes to the top. And I end up with an answer when I do -1 of 3. So I go over 1 and up 3. Now I need to have 3 distinct points. I'm going to probably at this time choose to do a -1, 3 is right here. So I'm going to choose to do now probably a +1. Well, if I raise it to the +1 power, it's still going to be 1 over 3. I now have 3 distinct points. That's enough for me to see the basic shape of this exponential function. Here, I'm going to have a vertical shift down 3, so I automatically go down here to -2. Oh, I'm saying the wrong numbers here as I'm trying to rush. I have a vertical shift of down 2. Please make sure she gets the paper she comes in. I also have a horizontal shift. Am I going to go to the right 3 or to the left 3? Left 3. So I'm going to make my own little list over here, and X and Y. And I think I'm going to start with -3 to make my life easy. So if I plug in -3 here, -3 times 3 is 0. Anything to the 0, anything to the 0 is 1. And 1 subtract 2 is -1. So I'm going to go over to -3 and down 1. All right, now I have a choice. Do I want to go to the left? That's -4 to -2. I think I'm going to try -4 next. So I'm going to flip this over, and I'm going to write -4 into this position. So -4 plus 3 is -1. I recognize that this simply means it's going to be the reciprocal. If you are going to take this and distribute it, you get 1 to the -1 over 3 to the -1. That simply means reciprocal. So 3 over 1 comes from this portion. Subtract 2. 3 over 1 subtract 2 is simply 1. So I'm going to go over 4 and up 1. And I can now see this general shape. See how we have simply shifted it down 2, and then we've shifted it to the left 3. I do need to be able to identify the y-intercept, and so I'm now going to plug in 0. When I plug in 0, I'm going to come back here so I can see this. When I plug in 0, I have 1 over 3, 0 plus 3, subtract 2. So 0 plus 3 is simply 3. Now I need to distribute that. That's 1 to the third over 3 to the third. You have no calculator. So I have 1 over, not 9. I saw 9 as I walked around. 1 over 27, subtract 2. I need to write 2 as a fraction, and I want the common denominator to be 27. If you see any mistakes, let me know. What's 27 times 2? I believe it's 54. 1 subtract 54 is -53 over 27. 0 and -53 over 27. And we can see this general shape that we have as it goes along here. Do not give me a decimal unless it terminates. That means do not give me a decimal in which you are rounding. All right, now what is the difference here when we have a negative out front? Let's look up here. What happens when we have a negative out front? What does it do? It flips across the what? Reflects across the x-axis. So if I was going to take a guess what this looks like, instead of it going like this, it's going to go like this. But we also see that shifted up too. By a raise of hands in class, how many of you have already attempted B and C? Hands up high. Okay, so I will continue to go since we have at least half of you at that point. All right, so here we go. I'm going to start by making my little, by getting a piece of paper here. And I recognize that this is the same as f of x equals -1, and then 1/3 to the negative x. Ooh, we have a bunch of things going on here. So I can see we have a reflection across the x and the y axis. I did not see that prior. So let's talk about what this may look like. I'm going to make my little list up, and I'm going to start by plugging in 0. So anything raised to, well, -0 is not even such a value. So anything raised to the 0 power is 1. I have a -1. This becomes 1 plus 2. -1 plus 2 is 1. So I'm going to go to 0, 1. 0, 1, I make a dot. I come over here, 0, 1. All right, I'm going to try doing 1 now. So if I plug in 1, this becomes a -1. So I have 1/3 raised to the -1 plus 2. We've already talked about when you have a -1 as an exponent, what that does is it means reciprocal. So I have a -3 plus 2. -3 plus 2 is a -1. I'm going over 1 and down 1. And I can already see what this looks like. And I have a choice now to do a -1. I have a choice to plug in a positive, whatever, or positive 2, whatever you choose to do. I think I'm going to plug in, I don't know. I think I'm going to plug in a positive 2. I think it'll be less fractions for me to work with. You could choose either one. I have a negative sign out front. When I plug in a positive 2, I have 1 over 3 raised to the -2 because there's already a negative sign there. Remember, the negative sign means reciprocal. So what I end up getting is I have 1 to the negative 2 over 3 to the negative 2 plus 2. And that's much easier than you actually think. It's much easier than you actually think. What that looks like is we have negative 1. I'm going to flip them. 1 goes to the bottom, and 3 goes to the top, plus 2. 3 squared is 9. And now I have negative 9 plus 2, which is negative 7. Negative 7. So I'm going to go, I had plugged in here, let me go back to my little table. I plugged in a 2 and I came up with a negative 7. So I'm going to go over 2 and down 7, and we can see the general shape of this. It's okay to do it differently as long as you are getting the right answer. So let's take a look here. I know that I'm going to have a vertical shift of up 1. Okay. And then I'm going to write f of x equals 1/3 negative x minus 1 plus 1. And I'm going to make my little list here. And I'm going to start by plugging in 0. So if I plug in 0, I have 0 minus 1. So I have 1/3. Again, I plug in 0. This equates to negative 1 plus 1. A negative 1 simply takes the reciprocal, so I flip it around, and I end up with 4. So I'm going to go to 0, 4. So 0, 4, 2, and 4. All right, now I'm going to plug in a positive. Let's go with a positive one. Okay, so if I grab another little sticker here to help me out, if I plug in a positive 1, I end up with 1/3. Plugging in a positive 1, minus 1 plus 1, 1/3. And we have negative 2 plus 1. Now this means reciprocal. So first I'm going to distribute it. And I'll put this down so that you can see if you are watching this recording. So I have 1 over 3. Now when I distribute, I get a negative 2 and a negative 2 plus 1. What does this mean? It needs to go down the bottom. 1 squared up top. We're taking the reciprocal. And I have 9 plus 1 is 10. So when I substituted in 1, I got an answer of 10. So we know we can't go way over here, but it's looking something like this. So I already know it's going to be going down like that. Let's check right now with the negative 1 since I do need to have 3 points. So now I'm going to plug in negative 1. Okay, so when I plug in negative 1, I have 1/3. I plug in, there's already a negative sign. Now I substitute in negative 1 minus 1 plus 1. Well, 2 negatives make a positive, and 1 minus 1 is 0. So 1/3 to the 0 plus 1. Anything to the 0 is 1, and 1 plus 1 is 2. I'm going to go over 1 and up 2. I have 3 distinct points, and I do need to label the y-intercept.